What we're going to do is we're going to look at some properties of acids and bases. We're going to make a table and make a comparison between these. And in our table, we'll put on the left-hand side acids, and on the right-hand side we'll put in bases. And then we'll kind of list those properties that each of these would have. And so we'll start by looking at the acids. First of all, another name for acids is corrosives. So if you hear the term corrosives applied, it's referring to something that is acidic. And on the basic side, another term for bases would be alkalis, or sometimes alkaline, or caustics. Now, where have you heard alkali or alkaline used before? Batteries, yes. In fact, if you ever had a battery, like an alkaline battery, leak before, and feel that stuff, you're going to want to wash that stuff off, because that stuff that comes out of there is a paste that's very similar to the lye that you used in your soap lab last week, and it will feel slippery on your skin because what it's doing is converting the fat in your skin to soap. And so those alkaline batteries, they're very economical to make, but if they do get some sort of hole and start leaking, they will start reacting with your skin. Now, the word acid comes from the Latin word acidus, which means sour. And so we often say then that acids have a sour taste. But we don't run around tasting acids. You don't see me sitting here drinking stuff out of here, because, of course, some acids we can taste. In fact, if we tasted something that's sour, what would be an example of something that's sour? Lemons, exactly. Everybody would agree that a lemon is. Vinegar is often something else described as having a sour taste, and those are acidic. And then bases, we often say these have a bitter taste. Not a better, but a bitter taste. Anything that anyone could describe as having a bitter taste? Well, I don't know if you ever tasted unsweetened chocolate before, but unsweetened chocolate is something that would be a bitter taste. In fact, if you look at a package, you'll say it's processed with alkaloids, or with, what is it? Processed with alkalis, yes. And coffee, the flavor components in coffee are called alkaloids, and so they impart some sort of bitter taste to it. I'm trying to think of that vegetable I eat, like a bitter squash or bitter cucumber. But if you've had some non-American veggies, you may have tasted some that have a bitter taste as well. Then, as far as some other properties, we say that the acids, these cause skin burns when concentrated. And on the basic side, same thing. Bases as well. If it's concentrated, they will cause skin burns. We also mentioned that they affect the colors of acid-base indicators. And so we saw some of those here today. Bases will obviously do the same thing. And like Gloria, having done the lab with the red cabbage, saw that the colors changed. Most acid-base indicators actually originally derived from natural sources. So red cabbage was one. We didn't say it at the time when you used it in the lab, but if you used litmus paper for anything, like you were testing, I think when you did the penny lab to see whether your solution was basic enough, we had strips of litmus paper. Well, those strips of litmus paper had been soaked in a big batch of dye that had been extracted from what's called the litmus moss. And so it's a plant, and many of these acid-base indicators do have these natural plant sources where they came from. Something else that you observed in lab for acids is that they react with certain metals. To produce hydrogen gas. And we also saw that they react with carbonates and bicarbonates. This is also something else you did in lab. And when they react with carbonates and bicarbonates, they wind up producing carbon dioxide gas. So again, these are things that you did. You might remember in the gas lab you did some different reactions where you were mixing things together. And the first one, I think you took magnesium metal and some vinegar to make the hydrogen gas. And then on the second one, I think you took some marble chips and some hydrochloric acid to make the carbon dioxide gas. Then on the base side, this is another thing that if you were working with a soap lab, we say that these feel slippery on the skin. And the reason why they feel slippery on the skin is that it's just like in your lab. In your lab, you took a base. The base you used was lye. You combine that with lard or the vegetable shortening, and you used it to make soap. And so the lard or the vegetable shortening is a type of fat. And so, as we mentioned before, if you get a base on your skin, it's going to feel slippery because it's basically reacting with the fat in your skin to make soap. And so the first thing I would always do if you're working with a chemical and you get it on your skin and you feel it's slippery, get rid of it right away, because ultimately it's going to wind up causing some skin burns, and it'll dry, strip all the oils and moisture out of your skins, and then leave behind the possibly some burns if it's concentrated enough. Any questions on these?